All right, Class 2 YouTube video, Chapter 2, Question 1. What is the total number of scores for the distribution shown in the following table? Here, all you're doing is adding up all the frequencies. The frequencies are F, and they reflect how many scores there are. So if you add up all these frequencies, you will get 14. Question 2. For the following frequency distribution of quiz scores, how many individuals took the quiz? Again, same as before, all you're doing is adding up the F column. Question 3. For the following distribution of quiz scores, if the score of X equals 3 or higher is needed for a passing grade, how many individuals passed? Well, you go to 3, you go over the frequencies of 5, you know 3 and above passed. How many are in 3 to 5? You do 5 plus 5 plus 6 equals 16. For the following distribution of quiz scores, how many individuals had a score of X equals 2? Well, you just go to 2, and you see that frequency is 3, so 3 is the answer. If a set of exam scores forms a symmetrical distribution, what can you conclude about the student scores? Well, a symmetrical distribution has 50% of scores on the left and 50% of scores on the right. So in general, the best answer for this would be about 50% of the students had high scores and the rest had low scores, which would mean 50% of the students had low scores. And the other answers just don't make sense. Relatively high scores would be negatively skewed, and relatively low scores would be positively skewed. What term is used to describe the shape of a distribution in which the scores pile up on the left-hand side of the graph and taper to the right? So when scores pile up to the left, like here, it is positively skewed. What is the shape of the distribution shown in the following graph? Well, they're piling up more to the left, so it's positively skewed. The skew is always where it tails off. A skew distribution typically has one tail, and a normal distribution has two tails. So a skew distribution usually has only one tail. You could see here, skew, there's no tail here. There's just high numbers on one side, then this is the tail, where it basically tails off. On a normal distribution, there are two tails. The students in a psychology class seem to think that the midterm exam was very easy. If they are correct, what is the most likely shape for the distribution of exam scores? Well, if they think it was easy, then they probably all did very well. So that means the scores will pile up to the right. And if scores pile up to the right, that means it's negatively skewed. For the scores shown in the following stem and leaf display, what is the highest score in the distribution? Well, you could look at the stem, 8. So 8's the highest number in the stem. And in the leaf, that just represents other numbers. So 8 represents 80. So this would be 83, 81, and 84. Out of those numbers, it would be 84. If the following scores were placed in a stem and leaf display, how many leaves would be associated with a stem of 6? Well, a stem of 6 would be whatever scores are in the 60s, and there are 3 scores in the 60s, so the answer is 3. Find each value requested for the set of scores in the following frequency distribution table. So for n, you just add up the frequencies because that will tell you the number of scores. The sum of x, you're just adding up all the scores, right? And you have to remember that to look at the frequencies. So there's 1 5, there's 2 4s, there's 3 3s, and there's 5 2s. So if you add them all up, you'll get 32. You can also multiply across 5 times 1, 4 times 2, 3 times 3, 2 times 5. Add those up. You will also get 32. C, sum of x squared. Well, sum of x squared, we know we have to square each number individually and then add them. and take the frequencies into consideration. So here we just did 5 squared plus 4 squared plus 4 squared plus 3 squared plus 3 squared plus 3 squared, etc. Add them all up and you will get 104. Chapter 3. What is the general purpose? Is served by a good measure of central tendency. The purpose of central tendency is to identify a single score that serves as the best representative for an entire distribution, usually a score from the center of the distribution. In general, as far as where we are right now in the class, a normal distribution, the best center of tendency would be the mean, and on a skewed distribution, the best measure of central tendency would be the median. Find the mean, median, and mode for the following samples of scores. First thing you do is put the scores in order. The mean is simply the sum of scores divided by the number of scores, or the sum of x divided by n. 24 divided by 8 equals 3. Median equals the middle number. For even sets of numbers like this data shows, we take the two middle numbers and add them and divide by 2. So the two middle numbers are 3 and 2. So 3 plus 2 equals 5. 5 divided by 2 equals 2.5. Mode, the most frequent number, or numbers. So in this case, there's more 2's than any other number, so it would be 2. Well, for learning purposes, if there were 3 7's as well, then there would be 2 modes. It would be a bimodal distribution, and the modes would be 2 and 7. Find the mean, median, mode for the scores of the following frequency distribution table. So again, here you have to take the frequencies into account. Start from lowest to highest. There's 1 3, there's 2 4s, there's 2 5s, there's 2 6s, there's 4 7s, there's 1 8. Plot them down. Mean, simply add them up, divide by n, and you can get by adding up the frequencies. So that's how many scores there are. And then if you add all these up and divide by 12, you will get 5.75. The median is the two middle numbers because there are even amount of numbers. So you do 6 plus 6 equals 12 divided by 2 equals 6. In the mode, there are more 7's than any other number, so the mode is 7. A population with a mean of 10 has a sum of x of 250. How many scores are in the population? Well, we know the sum of x is 250 and the mean is 10. The mean is a representation of the average of all the scores. So if you take the sum of x and divide by the mean, you will get how many scores? 250 divided by 10 equals 25. A sample of n equals 5 scores has a mean of 12. If one person with a score of x equals 8 is removed from the sample, what is the value of the new mean? So the first thing we want to do is get the sum of x. So we do that by taking the mean and multiplying it by n. We get 60. Now, we're going to remove a score, so we're going to take the sum of x and remove 8, and that will be 52. And now, to get the new mean, we have to account for the score that we took away. So we're going to take the new sum of x, which is 52, and divide it by the new n, which is 4, and that will equal 13, which will give you the new mean. A sample of n equals 9 scores has a mean of 10. One person with a score of x equals 2 is removed from the sample. What is the value for the new sample mean? Again, we do 9 times 10, so n times the mean, or 10 times 9, either one, you get 90. Now we're subtracting the score of 2, which will leave the new sum of x is 88. So now the sample has n equals 8 scores, so 88 divided by 8 equals 11, right? We had to account for the n equals 9, so we also had to take away 1. That is why we were dividing by 8. A sample of n equals 7 scores has a mean of 9. One score in a sample is changed from x equals 19 to x equals 5. What is the value of the new sample mean? So the sum of x equals 63. We got that by doing the mean times n. 9 times 7 equals 63. Now we want to get the difference. So a score from 19 was changed to 5. So we want the difference of the changed score, which is 19 minus 5 equals 14. So now we get the new sum of x, which is 63, the original, minus 14, which is the difference of the score that was replaced. That equals 49. The new sample mean is 49 divided by 7. We did not change the n because all we did was replace a score. We did not remove a score. A population of n equals 16 scores has a mean of 20. After one score is removed from the population, the new mean is found to be 19. What is the value of the score that was removed? Hint, compare the values of the sum of x before and after the score is removed. So the sum of x before is 16 times 20 equals 320. The sum of x with the removed score is 15 times 19, right? Because the new mean is 19 and the score was removed, so the new n is 15. So now to get the difference of that, we do the original sum of x, which is 320, subtracted by the new sum of x, which is 285, which equals 35. So that must mean that the score that was removed was the value of 35. Identify the circumstances in which the median rather than the mean is preferred measure of central tendency. So you could just read this, and as far as this class goes at this point, really just understand that the median is really used instead of the mean with skewed distributions. So the College of Staten Island basketball team faced off against Brooklyn College. The starting 5 players from CSI scored 7, 31, 17, 11, and 9 points. Brooklyn College starting 5 scored 2, 21, 13, 17, and 5. A Brooklyn College player was injured early on in the game, and a substitute took his place. That substitute scored 14 points. Find the weighted mean, or combined mean, of the n equals 6 Brooklyn College players and the n equals 5 CSI players. All right, you can find this formula on page 77. But the formula is simply the sum of x1, which is the sum of the CSI scores, and the sum of x2, which is the Brooklyn scores, divided by the n of CSI, which is 5, or n1, and the n of Brooklyn, which is 6, right? I specified that n is 6 because we were adding the substitute score to the group. So now to get the weighted mean, you simply take the sum of x of CSI, 75, plus Brooklyn College, 72, which is 147. 5 plus 6 is 11. 147 divided by 11 is 13.36. That is the weighted mean. Chapter 4. The following data has been collected on the amount of times n equals 5 students talk during class. The recorded data is 15742. Fill out the table and compute SS, also known as sum of squares, variance, and standard deviation for this sample using the computational formula. So when we use the computational formula, we want to first get the sum of x and the sum of x squared. You simply plot all the x values and get the sum. You add up these values, you'll get 19. Then you square all the x values, you add them up, then you get the sum of x squared. Then you plug them into the formula. So you're going to do 95, because that's the sum of x squared, minus 19 squared divided by 5, which equals 95 minus 72, 72.2, which equals 22.8. Now for the variance of a sample, you simply take the sum of squares and divide it by n minus 1. In this case, n was 5, so we're going to divide by 5 minus 1, which is also 4. So 22.8 divided by 4 equals 5.7. Now to get the standard deviation, you just take the square root of the variance. Square root of 5.7 equals 2.39 rounded to 2 decimal places. Now we're going to do the same question looking at the definitional formula. So it's the same question and we start the same way. So we plot all the x's. Now what changes is we are going to want to get the mean. So we know that the sum of x is 19, n is 5, so 19 divided by 5 is 3.8. Now, x minus m is the deviation from the mean of each score. Basically, each x minus the mean. So when you do 1 minus 3.8, 5 minus 3.8, 7 minus 3.8, 4 minus 3.8, and 2 minus 3.8, you get all of these values. Now, last step is you take all those values and square them. When you square them all, remember, when you square a number, it's always positive. You get 22.8. As you could see, doing it the computational way, we got 22.8. Doing it the definitional way, we got 22.8. So the rest of the values will be the same for the rest of the question. Last question. The following data has been collected on the amount of times N equals 7 professors make errors during the semester. The recorded data is 1357428. Fill out the table, compute SS variance, standard deviation for the sample using the definitional formula. So you take x, add them up, sum of x is 30. Then you square each individual x. Sum of x squared is 168. Now you just plug everything into this formula. So 168 minus 30 squared divided by 7 comes out to 168 minus 128.57, which equals 39.43. Now to get the variance of a sample, you're doing sum of squares divided by n minus 1. 39.43 divided by 6, which is 7 minus 1, equals 6.57. The standard deviation is just the square root of this variance. Square root of 6.57 is 2.56.